Hey, I probably should have split this into three videos. I apologize for the last one and the length. But let's look at some examples of drawing Lewis structures and working through that kind of rule set I just went through. Um, so example number one, draw the Lewis structure for PBr3. And this is phosphorus tribromide. Okay, so first let's identify the central atom. In this case, phosphorus is the first one. It is a single element in the formula. It also has more unpaired electrons than bromine. So we're going to assume that phosphorus is the central atom. I'm going to pull up a periodic table just so that we have it handy. So phosphorus is here. It has 5 valence electrons, and I'm going to draw those valence electrons out. And again, remind me to go over this because I think it makes drawing Lewis structures a little bit easier if we know where the electron placement is. Our next compound that we have is bromine, which is here, and we know that they have 7 valence electrons. So again, these lone electrons are probably going to be the ones that we attach our bond to. So I'm going to draw a bromine here, a bromine here, a bromine here. It has 7 valence electrons, so I'm going to go ahead and draw those. I like to replace the electrons with a bond. I think that's the easiest thing to do, but I understand, like, if you already know it, you know it. And again, we know these are going to pair together. So let's go ahead and pair these up, make single bonds. I realize that we didn't count our valence electrons. Let's do that really quick. Phosphorus has 5 electrons plus bromine 3 times 7. That equals 26 electrons. So phosphorus is in octet, has 1, 2, 3 bonds, so that's 6 electrons plus 2, that's 8 electrons. Each bromine has 8 electrons, so they're both an octet. Now let's count and make sure that our final structure has 26 electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. This is a great Lewis structure. I know because I drew it. Our next example that we want to look at is CH2O. So let's count our valence electrons. Carbon has, I don't know what's going on. Carbon has 4 valence electrons. Hydrogen has 1 valence electron, but there's 2 of them. And oxygen has 6. This gives us a total of 12 electrons. Now I'm going to use the rule that carbon comes first, so I'm going to make this the central atom. I'm going to pull up a periodic table if we need it. Carbon is here, oxygen's here, hydrogen's here. I'm going to put carbon. I'm going to draw my valence electrons, and I'm going to put both hydrogens on this side because I know that these electrons are going to be sharing And I know these electrons are going to be sharing. Now, oxygen has 6 valence electrons. So I'm going to draw them like this. Now, if I just connect one of these as a single bond, we're going to have an electron here that's not in a pair. And we can't have that. So I'm going to use what I know about multi-bonds, and I'm going to connect 2. And I think that's actually going to help us a lot. So I'm going to go ahead and fill in these bonds and see what our structure can look like. Okay. So our goal is that each atom has 8 electrons, except for hydrogen. Hydrogen has 2, and both the hydrogens have 2, so we're good. The carbon has 2, 4, 6, 8 electrons, so we're good there as well. And the oxygen has 2, 4, 5, 6, 7, 8 electrons, so we are good. Remember that these bonds, although they're coming from each of the atoms, they're being shared. So both the carbon and the oxygen own all the electrons in these bonds. The last thing that we need to do is make sure that we have 12 valence electrons, like we said at the beginning. So we have 2, 4, 6, 8, 10, 12. This is the Lewis structure for CH2O. The next example I want to go through, oh, I guess I'm going to do it in pink now, is C2H2 ethane. Carbon has, pull up a periodic table. Carbon has carbon has 4 valence electrons. We need to multiply this by 2 because there's 2 of them. And hydrogen has 2, there's 2 of them. Each of them has 1 valence electron. This has a total of 10 electrons. You can see here, there's only 4 atoms. There's no real central atoms, but I'm going to put both these carbons in the middle. Each of them have 4 valence electrons. And you know what? I'm just going to put the hydrogens on the outside because I like that. I think that's pretty aesthetically pleasing. So I'm going to connect these 2 with a single bond. And I'm going to do the same exact thing on this side. Connect both of those with a single bond. Now, if I only connect one bond, then this oxygen will only have 6 electrons in its octet. And we want it to have 8. So what I have to do with these is I have to make a triple bond. And this is the maximum bond that you can make. You can't have a quadruple bond because that's going to set the parameters off when we go to octet. So triple bond works here. Each carbon, each hydrogen is an octet. Does it have 10 electrons? Let's check. 2, 4, 6, 8, 10. Looks good. And the last example I'm going to do is ICl5. And this is iodine pentafluoride. I'm sorry, pentachloride. not fluoride. Iodine is the central atom. It is the first one. I'm going to go ahead and put this in the middle. Before I do that, let's count valence electrons. Iodine and chlorine are both in group 17. Chlorine is here, iodine's here. Iodine has 7 electrons, 5 times 7 for chlorine. That gives us a grand total of 42 electrons. So I'm going to go ahead and put iodine in the middle. And I'm going to draw its valence electrons as well. It has 7 of them. And then I'm going to put 5 chlorines around. And I'm going to draw all their valence electrons too. What's really nice about drawing Lewis structure sometimes is it's almost like a connect the dots type of thing. And you'll see that I draw the valence electrons so that the ones that I know I'm going to connect are facing that direction. And this will come with practice. I promise you're going to do a lot of examples in class, so don't stress. And basically what I'm going to do is I'm just going to connect these free electrons to create my Lewis structure. So the chlorines are an octet. Each chlorine has 8 electrons. The iodine, however, has 2, 4, 6, 8, 10, 12 electrons. But iodine is located below the 3rd period, and it has this d orbital to store electrons. So although it's not ideal, iodine having 12 electrons is okay. So again, last resort type thing, but if you need to go over octet, anything that has a number that's bigger than 4 here is probably going to go over octet, and that's totally fine. The last thing that we want to do is count the total number of electrons, which I'm going to do in green. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, and 42. We're in really good shape. That matches. If you feel like this was a little overwhelming, totally understand that. We're going to do a lot of practice. I specifically gave us enough time to do this over 2 class periods too, because I know it's a lot of work. We'll do lots of practice. Thank you for watching. Take care.